Hi, I'm Ma'am Naomi. Let's talk about construction technology education. The construction industry is an essential element of all societies. A quick glance at the surroundings reveals that there are many outputs from the construction system. The construction industry provides the built environment, and it consists of any and all structures that were produced where they are used. The built environment provides the surroundings in which people walk, sleep, eat, travel, work, and play. Structures shelter people and their possessions from the forces of nature and allow them to live in any climate. Industrial buildings and complexes are used to produce and store materials and products used throughout the world, even in space. First, let's define construction. According to Wikipedia, construction is a general term meaning the art and science to form objects, systems, or organizations. In its most widely used context, construction covers the processes involved in delivering buildings, infrastructures, and industrial facilities and associated activities through to the end of their life. Let's take a look at the conceptual model. It illustrates the three ways to describe construction projects: structure types, scale of construction project, and starting point of the project. Buildings and heavy engineering structures are two ways to categorize different types of structures. Buildings provide physical conditions that people want and need for themselves, their activities, and their belongings. Commercial buildings house retail stores, offices, and other similar types of firms. They are convenient to the customers they serve, pleasing to the eye, easy to arrange in terms of space, and inexpensive to build and use. Healthcare buildings, prisons, and post offices are examples of institutional buildings. Industrial buildings include factories where manufactured products are made and where materials, parts, machines, and finished products are received, stored, and shipped. Most high-rise buildings or skyscrapers are found in large cities where land costs are often quite high. Special purpose buildings are built for displays, sports contests, and transportation terminals. Heavy engineering projects include all other construction projects except building construction. The major kinds are industrial complexes, roadways, bridges, dams, pipelines, towers, ports, and tunnels. Most of these structures are designed by professional engineers. The scale of a construction project can be described in four ways. They are the number of structures, size of the structures, cost of the project, and complexity of structure in the project. All people participate at some level in the construction industry, but the key players are the owner, design professionals, constructors, related businesses, regulators, and users. The owner is the originator of the project and is usually responsible for identifying and leading the project team. Other participants are brought on board early so that their perspectives are represented in the discussions when alternative solutions are generated, developed, and selected. The context in which construction functions is changing rapidly. Structures are more and more complex. Their impact on the environment, people, and the economy is far greater than at any other time in history. Large sums of money, reputations, and resources are at stake, and people work on project teams to design and build structures so they can more effectively control cost, time, and quality. Quality in the constructed project is defined as meeting the requirements like quality, schedule, and budget of the owner, design professional, and constructor, while conforming to regulatory rules, laws, standards, and other matters of public policy. Construction technology is the efficient practice of using productive and management processes to transform materials and to assemble components into buildings and heavy engineering structures built on site. Technology used to manage the productive processes often differs. Some projects are built by the owner's employees, but larger projects often consist of one, two, or many prime contracts that are subcontracted by the owner. Separate contracts may be awarded to design the structure, clear the site, build the structure, and design and build supporting roads and parking. In the quest for higher quality, reduced time, and lower construction costs, new management processes are constantly being developed. Next is construction system. Mill Industrial Arts Curriculum Theory publication defined construction system as technical adaptive system designed by people to efficiently utilize resources to build structures or constructed works on a site. Constructed works are typically fixed on a site and are not moved. During the time period leading up to the early 1960s, few industrial arts education programs included content related to the construction industry. It was quite evident that many of the traditional approaches in industrial educations were incapable of providing students with an adequate understanding of the impact of construction industry upon our technological world. Our thinking and a major change in industrial arts education instructional content had to occur. The Industrial Arts Curriculum Project, or IACP, was the first systematic and thorough undertaking by the profession to develop rationally and to conceptualize the structure of an organized study of industry, a basic structure of the body of knowledge that defined industrial education with two elements: construction technology and manufacturing technology was developed. Management and personnel technology and community planning concepts were added to production technology. The management content include initiating the project, designing and engineering the project, and selecting a builder. Personnel technology consisted of contracting, collective bargaining, hiring, training, working, advancing, and handling grievances with mediation, arbitration, and strikes. In the mid-1960s, the goals, content, and activities for the industrial education profession had become confused. Controversy within and between the industrial arts and vocational education communities intensified. In the 1980s, confusion within the profession reigned as the literature in the field was replete with concerns and warnings about the direction and the future of industrial arts. The major contributions made by the Jackson Mill Industrial Arts Curriculum Theory Symposium participants were the following guidelines. A. Continue the shift of focus away from materials and processes and toward industry. B. Expand the curriculum base to include communication and transportation. C. Study both industry and technology within the context of the universal terms model, the past, present, and future, a global perspective, and the social and natural environments. And D. Consider the impact of technology. The subject matter of technology education, its organization, and methodology are all being challenged in the 1990s. Work by our national associations and efforts by individuals are impacting construction technology education. Construction technology was removed as an identifiable subject matter organizer and within 3 years reinstated. Efforts with a narrower scope are currently being made to produce more comprehensive, valid, relevant, and easily used organizers of subject matter, and to enhance the quality of the problem-solving experiences and image of construction courses. Construction regains its identity in the technological actions approach as identified by Wright in 1993. Wright noted that this approach includes the following: A. 4 technological actions: designing, producing, using, and assessing. B. Technological context: communication, construction, manufacturing, and transportation. C. 2 societal contexts: personal and commercial or industrial. The technological actions approach is used to produce artifacts and systems that satisfy wants and needs by solving problems and responding to opportunities. This model is useful to curriculum developers because it identifies the 4 basic and significant actions that effective citizens of a technological world employ, and it structures them in terms of their unique sequential actions. The search continues for more relevant curriculum models, improved ways to respond to the changing needs of society, and more instructional strategies that will help people understand and effectively manage a rapidly expanding knowledge base. Currently, subject-oriented curriculum innovations are being challenged by process-oriented curricula, in which students learn to solve problems and make decisions. The core process of a conceptual framework for technology education in 1990 is problem solving. In this model, construction technology has lost its identity because manufacturing and construction are joined to form production. Unfortunately, manufacturing content is most often selected as the example to communicate material processing and management technology in the production system. While connections and differences between construction and manufacturing should be emphasized, they are often only verbalized or ignored. Now, let's talk about construction industry in the future. In 1994, Ross wrote that the construction industry in the future will be characterized by certain trends, challenges, and projections. Technological advances, public and private sector relations, and pressure from market growth will fuel change in the construction industry. The COVID-19 pandemic has accelerated the adoption of digital technologies across industries. The construction industry is no exception. Digital construction has become the new normal for the industry. We bring you the top 5 construction technology trends to watch out in 2021, which will digitalize the construction industry. Building information technology is the de facto technology in the construction industry. With advancements in cloud technology, BIM is now even more accessible. Cloud-based BIM allows information about a project to be accessed by anyone in any location at any time. It improves project delivery by streamlining the exchange of design data and project management, resulting in more efficient design, construction, and operation processes. One of the most latest technological trends in recent years is the digital twin. A digital twin is a virtual representation of a building that collects real-world information about the structure via sensors. In construction industry, digital twin can virtually predict everything that will happen in the physical world, thus providing valuable insights to the architects, engineers, and contractors. Immersive technologies such as augmented reality and virtual reality have enabled construction companies and customers to visualize elements of the design, build, and post-construction phases of their projects in real time. Geo-enabled technologies have unlocked the potential of location data to drive informed decision-making, process standardization, and efficiency in these times of physical distancing. Technologies such as LiDAR and sensors are used to obtain data, measurements, and quantities over the life cycle of a project. Drones are also becoming increasingly popular to provide on-site digital asset tracking, continuous spatial inspection, and progress monitoring. The 3D printing industry and DFMA solutions are increasingly seeing application in construction projects all over the world. 3D printing can produce buildings and components at a fraction of the price and time than the traditional construction methods, thereby improving productivity. DFMA's design approach that focuses on ease of manufacture and efficiency of assembly in construction workflow processes. Thus, digital construction is the great reset for the construction industry, an opportunity in a crisis indeed. The real challenge is building structures in space. Some refer to space as our last frontier. Constructed structures in space are not built on a site and anchored to the Earth. They are built at a site and held in space. Footings and anchors hold structures to the Earth, while a balance of centrifugal and centripetal forces hold structures in space. Unfortunately, construction courses in technology education classrooms have not been very popular. The results of a 1990 CIWF study cited in Home Builders Institute indicated that junior high and high school students have a negative image of construction. The report stated that females felt excluded and that both male and females felt construction work was boring, tiring, stressful, dirty, and sweaty. The challenge before technology educators is to develop courses that result in valid competencies and to use engaging strategies that project a positive image without glamorizing or misrepresenting construction activity. A valid construction program should do the following: A. Help secondary students to value the industry that builds, maintains, and renovates our nation's structures and directly or indirectly provides jobs for 20% of the workforce. B. Ensures that graduates are able to respond positively and creatively to problems, issues, and opportunities they will experience in the future. And C. Make connections between construction technology and economics, languages, sciences, and mathematics. Students need accurate information regarding career opportunities. Teachers of construction courses in technology education must find ways to improve the image of construction without conveying a glamorized, possibly deceptive view of the construction industry. Comprehensive construction programs should include effective, productive, and management processes used by owners, designers, and constructors to design, build, and use structures. Construction experiences should provide students with opportunities to use this generalized subject matter to design, plan, and construct a built environment that offers an improved higher quality of life and favorable environment, sustainable energy resources, and physical mental wellness, well-being, and physical longevity. Traditional construction courses focus on the skills used to draw and build houses, skills which have limited appeal and utility. More students would benefit from a curriculum with a broader vision and one that reflects the expanding richness of construction technology. Subject matter in a construction technology program should include effective management and efficient processes used by owners, designers, and constructors to design, build, and use structures that are of high quality and are built on time and within budget. Activities should be based on current practices and sound economic principles. The image of construction and construction courses would be enhanced greatly if construction technology teachers would do the following. First, find ways to make students active participants in their own learning. Second, repeatedly stress the importance of employees being able to work as a team. The figure illustrates the major elements of the concept of applications-based instruction, which has the following characteristics. It is student-centered and allows the students to do much of the decision-making. It employs real-world scenarios selected from local concerns whenever possible. It has carefully stated outcomes reflecting state or local proficiencies. It uses problem-solving methods extensively. It addresses learning styles by using a variety of techniques to teach and assess. It uses effective group learning strategies to enhance achievement, develop a positive self-esteem, practice social skills, and improve group participation. It integrates subject matter in appropriate ways. Construction technology teachers were challenged to create construction courses. These courses must contain valid competencies, appropriate subject matter, and effective strategies that will produce a construction-literate populace able to participate in addressing current problems and issues, and able to reduce the potential of having a critical labor shortage in the near future.